Okay, so we will start off with views. We have discussed this views, the concept of views long back when we were talking about the introduction to databases in general, and we looked at the 3 schema architecture for a relational database management system, and we said that there is this the physical schema, then the conceptual schema, and then the view level schema. So, the view level schema basically contained views, and views are kind of virtual relations, and they are as we have seen earlier that they are actually provided to give a specific user group a particular view of the database without giving the full access to the database. We give them a restricted view of the database for various reasons, for especially for the reason of hiding unnecessary data, to be hiding the data and then exposing only the data that is necessary to be seen by that group of individuals. So, there we have only seen it as a concept, and now that we know SQL and then query specification, we can exactly see how how this concept of views is actually realized. Okay. So, in general these are they can the existence of views can also simplify the query formulations, and of course, it achieves the objective of data hiding. That means, we do not want to expose the data that is not necessary to be seen and by one group of people. Then supposing there is some particular kind of data that is frequently accessed, then we might and it is not one of the it is not one of the actual tables in the database. Okay, then we may be able to create a view consisting of this data that is frequently accessed, and then actually improve the efficiency of query answering. So, these are various possibilities when we have views. So, once we create these views, we will see how exactly we will create these views. It is the view is kept up to date by the RDBMS system. So, we give the responsibility of keeping this information that is there in the view to the up to date to the RDBMS system. So, notice that the actual data is there in the base tables. We call them as the base tables, the tables that have been created as part of the create table commands that we have given, and these are the base tables that are data is available in them. And then views will be created by making use of this information that is there in the base table as virtual tables, and we will see how exactly we will declare a view. So, in these, obviously, when data changes in the base tables, the views will have to be changed. The data in the views will go through those changes, that appropriate changes. So, this propagation of the changes that is done in the base tables to the views, and then keeping them up to date is the responsibility of the RDBMS system. So, once we declare something as a view, we can always assume that it is accurate, because the RDBMS takes the responsibility of keeping it up to date while the changes are actually happening on the base tables. And okay, this is I have already mentioned this, that views are not really part of the conceptual schema, but they are kind of created to give a particular user group or a particular concerned with certain aspect of the entire enterprise, their view of the system. Now, as far as the implementation of this idea of views is concerned, there are multiple approaches. It is possible that we do not actually keep the view as a permanent table in the database, but just keep the definition of the view alone in the database, and then kind of create that view as and when it is required. If it is being used in a particular query, then create that view and then make use of that. Okay. So, to give you a heads up, basically we will now be looking at how to create a view, but the view will be actually created as a result of a particular query. Okay. So, that query will constitute the definition of the view. Okay. So, we have the definition of the view and that will always be stored in the database management system, and so we now then have option of whether to keep the view already created. So, in such case it is called materialized. So, we materialize the view and then keep it as a as an additional table, as an additional relation in the apart from the base tables, and then of course, incrementally keep updating it. So, multiple ways of implementing this idea of view. So, there are two possibilities. One is to create this view as and when is required and use it, and then kind of discard it actually, and then whenever again it is required, it can be created. The other one is to materialize it, that means keep it computed, but then if you materialize it, then you have to keep it up to date. So, you have to take recourse to the incremental updates as and when data changes in the base tables, keep on propagating those updates to these materialized views. There is also another approach actually, that since anyway views are going to be used in in querying. So, supposing a query has been stated on a view, can we transform that query so that it is translated into an equivalent query on the base tables? That is another approach, but usually it is a little bit more complicated to transform a query, SQL query, which is using a certain virtual table into the one that does not use that virtual table, but uses only the base tables. So, that approach of query transformation is a little complicated, and normally it is not used, but these are the other two approaches where you can keep the view materialized, or if it is not so frequently used, then you compute it as and when it is required and then make use of it. So, these are the two options of implementing this idea of a view. Okay. So, let us now start looking at exactly how the view definitions are made. So, the tables involved in the view definitions are obviously I have been using the term base tables. So, these are the tables that have been created as part of the conceptual schema, and they are all available for us. Okay. So, SQL gives this command create view, name of the view as keyword, and then a query expression. Okay. So, okay. What this does is to create a view named V with the structure and the data as defined by this query expression basically. Okay. Okay, let us look at an example. So, create a view which contains name, employee ID and phone numbers of professors who joined the CSC department in or after the year 2000. For some reason we want to have the details of these people. So, we can now give a name for that, profs after 2K, and then basically supply the corresponding query. So, this query is now seen as a view definition, but what it actually is doing is to compute this required information. So, the professors who joined the CSC department on in or after 2000 is actually realized by this particular executing this particular query, okay. And then the we want this this profs after 2k is now going to be a relation name that is going to be available for us, because we created it as a view. So, we can freely now use this in other queries, okay. And it is up to the RDBMS to make use of this definition and then compute this query compute the view data and then use it wherever this definition with this particular relation or table name is actually used, okay. If in a query, if you use this, then the RDBMS will compute the information using this particular query and then make use of that in that query. Okay, so the query itself is very simple. So, I do not want to spend time on that. So, you can just see that we are putting some conditions on the start year greater than or equal to 2000 and then picking up appropriate faculty data. Okay. Now, so this particular relation will be kept up to date by the RDBMS system as and when changes happen in the professor table. So, if new professors join the computer science department, then this particular thing will automatically get updated. Okay. So, once we create it, it can be used as I said, you can always use it in queries just like any other table is being used. So, I will give you some illustrations of that. So, names of professors in whose name starts with Ravi or Ram or something. So, it is some query. So, now we are using so far in all our queries we have been using the tables that are part of the relation scheme. Now, we started using the view names. Of course, in order to write queries of this kind, we should also whoever is writing these queries should know what are all the views that are available, right. So, generally this notion of views is going to be used in order to create a set of tables, a set of temporary virtual tables to give a certain kind restricted information for a user group, as I was earlier stating. Yeah. So, whatever the definition what we have seen in the earlier slide is stored in the DBMS, and then when it encounters this query, it will create either create the temporary table and use it, or if it had already materialized it, it would use that anyway. Now, while querying is allowed, what about any update operations? Do they make sense? So, we want to discuss this issue of updating, though the actual query actual SQL commands that are going to be used for update operation, I will talk about them a little later, but let us say we know how to update a table, right. So, updating a table. So, that means updating information in particular in a particular attribute of a particular table. We will see how exactly it can be done in SQL. But then okay, when you look at updates on views itself, usually that would not make sense, and I will tell you why it does not make sense. So, and because of that, the updates on views are going to be heavily restricted. and the main reason for that is to kind of update the view, we may actually require to modify the many base tables, because it is possible that the view makes use of many base tables, you know. So, in the query in the view definition, many base tables might be involved. Also, there may not be a unique way of updating the base tables to reflect the update on the view. And sometimes views may actually also contain some aggregate function values, in which case it does not make sense. So, I will give you examples for all these things now. If the primary key of the base table is not included in the view definition, there could be then there could be even ambiguity as to what is the update that has to be performed. So, we will look at examples for all of these things. Okay. So, let us say we have a view which is created like this. I want to illustrate that if a view is created by joining more than one table, okay, then it is not, you know, good to encourage any kind of updates on that view at all. So, in order to illustrate that, let us look at this the query view. What is this view doing? Create a view student grades with roll number, name, course ID and grade. Okay. So, how do we create that? Create view student grade, roll number, name, course ID and grade. Where is that information is coming from? You have the schema with you. So, from student and enrollment we can get this information. Basically, we are one more thing you see here, that we are not keeping track of when that particular student has completed that course. We are dropping off the semester year information. The enrollment table has other details as to when that particular student has done the course and obtained the grade. So, we are dropping off all that information here to get us to kind of get the transcript of the student kind of thing. So, roll number, name, course ID, grade is there. So, of course, it is easy to get this, because all that we have to do is to join student and enrollment with this and then impose this condition saying that roll number should be equal to the E dot roll number and pick up name from the student. Okay. Now, why is supposing if I take this view now and then suddenly decide that, you know, let me update the grade value for some student in some course, for a particular student in a particular course, let me upgrade his grade from U to some D or something like that. Okay. Suppose a student has not cleared a course. Suppose a student has not cleared a course and he got U grade, then he is kind of repeating the course. Then what will happen in this particular result of the view? The same the student will appear with that course ID multiple times, right. If you have cleared the course, then you would apply it only once. If you not cleared it and it is a core course and it has to be cleared, so the student might appear actually multiple times. Suppose he has taken it 2 times and then unfortunately both times he is not cleared the course, let us say, then in fact there will be only one record here, because semester and year are dropped out from this particular thing. There will be one record saying that this particular student has done that and got a U grade, even though he has done it 2 times. Now, let us say you want to do this upgrade, saying that the grade value for a particular course for a particular student has to be upgraded from U to D. There is obviously ambiguity here, because we do not know which of those, of course, we can which of those underlying in the enrollment table, for what semester and what year will you upgrade it from U to D, because he might have done it, he has done it 2 or 3 times or so, whatever. So, of course, we may take a policy here saying that the last time he has done course might be upgraded, but in general you can see the ambiguity, because it is result, the view is the result of joining multiple tables, and there are multiple more than one way in which the base tables can actually be upgraded to give this join, which is the result of this particular query. So, since there is going to be ambiguity when multiple tables are involved in the view definition, and a upgrade a change in one of the attribute values might actually be realized by multiple ways of changing the base tables. Because of all these reasons, we basically do not allow any updates to be done on any view that is defined by joining more than one table. Okay. So, that is a there is a reason why we restrict it like that. In a similar way, supposing the view is created by making use of a group by and an aggregate function. Let us look at this view. What this view is doing is to compute what is the average number of credits of the courses that are offered by a particular all departments. Okay. Across all departments, we want to now find out what is the for all the courses that they are offering. You look at the credits and then take the average of the credits and then report that. How do you do that? Select department number and average of credits, which is a aggregate function, and do a group by department number. Okay. If you recall, what we basically doing here is that the course tuples will be grouped in department wise, partition department wise, and for each department we will be computing the average, and then that is the table will now have department number and average credits. So, it is obviously does not make sense to kind of go and update this average credits attribute, because it is not it does not make sense at all, because there are multiple ways in which the credits could have changed to create that average, right, to the updated average. So, so updates on this kind of views which involve using the aggregates will not be allowed at all. Again, you can see that the main reason is that the update on this particular attribute, for example, average credits, cannot be uniquely mapped to any update on the base tables. That is the reason. Okay. Moving on, in a similar spirit, if the primary key is not included as part of the definition, so views in which do not include the primary key of the base tables will also be not permitted. Again, the reason is that the update on the view can be mapped in multiple ways to the updates on the base table. So, let us say here is I create a view student phone with student name and phone number. Student name is not a key. So, so you are just projecting name and phone from student, and so there will be so many Kumars with so many phones, and then If you try and update some Kumar's phone number, then you will be in trouble. Which Kumar is this? So, basically to kind of summarize, what we are doing is allow updates on views only if the view is defined on a single base table and it is not defined using any group by clause or aggregate functions, and the view definition includes the primary key of the base table. If the view definition includes the binary includes the primary key of the base table, then there is a possibility for uniquely propagating the update to the base table, and so that is the restrictions on updating views. Okay. So, basically to kind of summarize this concept of views, it is possible for us to create a bunch of virtual relations which will give a restricted view of the information system for use of a group of individuals, and these virtual relations can then be used by those group of people for querying information. Okay. And by and large updates on these things will not be will not most of the time make sense, and if they make sense only, they will be allowed. So, that is the kind of summary on the views, but they are of course very useful because they will create they will give us that particular group of individuals access to the part of the information system that they are allowed to make use of. Okay. And in general, the RDBMS takes responsibility of keeping all these virtual relations up to date by its own mechanism. We do not care about how exactly it does it. It might do it through materialization or through creating these views as and when it is required to be used. Good. So, that is the and in general this feature of views itself is a little advanced feature that, and some RDBMSs might not even provide this facility. Okay. So, it is part of the standard of course. If you have views, what should be done and how they should be created is all part of the SQL standard. So, a particular RDBMS might not even implement this feature, it might just give you a basic version of SQL. And most enterprises whose operations do not read these things might be able to make use of such a RDBMS even. Okay. So, now let us go on to looking at a few other features of SQL, which are basically to do with updating data. So, now that we have been actually the reason why I am discussing updating inserting data towards the end instead of doing it at the beginning is that while updating also it is possible for us to kind of use querying. That is the reason why we are discussing updates and inserting data towards the end actually. Okay. So, let us see how to insert data into the tables. So, there are SQL constructs for doing that. So, insert into and then the relation name, values is a keyword, and then you can supply a comma separated tuples ending with a semicolon, so that all this data goes into that particular thing. Of course, you should put values in quotes and then they should all be comma separated. So, of course, the RDBMS might give you loading data loading functionality in which it might take data from multiple formats and then actually store it into the tables, but this is the SQL commands that I am talking about. There may be other ways of bulk loading data into the database, in which case it might take data from say spreadsheets or CSV files and things like that. It is also possible for us to insert data by giving a query. This is the reason why we are discussing this at this stage. So, insert into some relation and then give a query, a select from where. So, the entire result of that particular query will be inserted into this possibly new relation. We can also specify that some subtuple be inserted. So, select insert into student roll number name sex alone. So, you are giving what is the scheme of the subtuple here, and then values. Of course, these values, the tuples that here should obviously match this number, and then the data types we can give like this. So, the assumption here is that the rest of the attributes will be updated later, or will be inserted as default values or something like that. So, typically, so if you do not declare, if you do not insert data, then either the attributes, if it is allowed to be null, then null will be used, and if you have access to the default values, then default values will be used. Okay. So, inserting data into the tables can be done like this. Then deleting stuff from the deleting rows from tables. So, deleting of tuples is obviously possible, but deleting any part of the tuple is not possible. You have to drop the entire row. Okay. Now, deletion of tuples can only be done from one relation at a time. You cannot delete tuples from multiple relations at the same time. So, notice one thing, that while you are deleting rows, it might trigger our referential integrity constraint violations, it might trigger some actions. So, because one tuple goes from one relation, then it is being referred to, it is being referred from other tuple from another relation, and there might be referentially triggered actions defined in that case, in which case the deletion might cascade and all that. So, one has to be aware of those issues when you are doing deletions. So, the generic form for deleting a row is delete from the table name where predicates. So, all those rows that satisfy these predicates will be deleted from the thing. So, here is an example. People have retired. So, delete tuples from professor relation with start year as 1982. So, delete from professor where start year equals 1982. Simple. But one has to be careful about one aspect about deletion. Let me tell you that. Okay, before you going there, if the where clause is not specified, then the whole of the data will be deleted. So, we have to be careful about it, because you know that where clause, if it is not specified, it is taken as true, right, always true. So, one has to be careful about that. So, see, here is another interesting aspect of deletion that we have to be aware of. The where predicate actually is evaluated for each of the tuples in the relation, and then we mark them as being qualified for deletion, and only then after we mark all of them we start deleting. Okay. So, before deleting any tuples, we are going to mark all those tuples that qualify the where condition that is specified. This is very important, as you will see, this is very important actually. The result of deleting these rows as and when they are satisfying the where condition is a little dangerous. Let me illustrate that with a query here. You recall that we had a get marks thing. So, delete all tuples of students that scored the least marks in the CS branch, let us say. Okay. So, delete from get marks where branch equals computer science and marks is equal to, you have a subquery to compute the minimum marks in the branch computer science. So, if the marks equal to the minimum marks, then you delete that row. Now, here you can see the danger, right. You can see the danger here very clearly, that if you start deleting as and when a tuple satisfies this condition, then actually what will happen? What will happen? One by one, all the students of computer science branch will get deleted, because at some point of time everybody will become minimum among the remaining students, and so it is a dangerous thing, right. So, that is why it is very important for us to mark all the rows that satisfy the where condition and then go about deleting them after marking. Okay. So, this is one aspect you have to be careful about. Now, let us come to the actual updates. We have been talking about updates. So, what is the constructs for doing update? So, update relation, here is a keyword set and then attribute, what is the attribute and what is the new value. So, that kind of a list we can give, a list of attribute value pairs with the equality in between you can give. Again we can give a predicate here saying that for all those rows that satisfy this particular condition, you update the value to this new value. So, change the phone numbers of all professors working in CSE department to something, that is a dangerous thing, but anyway let us see how to do that. So, update professors, that is the relation name, set phone equals so and so, where department, so department number equals department, so you do not know the department number of computer science. So, you are selecting this could be equal to or in also, right, equal to any, it should be equal to any. So, this subquery gives you the department ID of CSE department. So, for all these people we are now setting the phone number to something. Is that a valid phone number at all? Okay, it looks like that. Of course, if where clause is not specified, then it is dangerous, because all tuples will be changed. So, one has to be careful about it. So, this is how updates happen. You can, so this here I gave one attribute and one value. You can give a list actually, you can also give a list of such pairs. Then other miscellaneous features of SQL which we have seen. There is a interesting clause called order by clause, that is new here. Order by is basically used after the query result is computed. You can order the tuples of the result by making use of the attributes that have been specified here. So, in this case select name professor where start year equals greater than 1980, order by name. So, the professors names will be listed in alphabetical order, because that is how we order. So, the default thing is ascending, then you can control whether it should be descending by giving a keyword called descending in this case. If you do not give anything, it is ascending value. So, it will be arranged in alphabetically increasing order. So, order by clause is available. So, please pick up the information about. So, you can also order by multiple attributes, So, again lexicographic ordering will be used. You can also check whether something is actually null, the value is null or not. Okay. So, is null is a predicate that can be used in where clauses. The null values in SQL tables could be present for various reasons, because you do not know the exact value or the value is not applicable, etc. So, for multiple reasons there could be a null value, and you can check whether the actual value is null. And it is recommended to use these things rather than yeah. So, the equal to null does not work actually, it is this is null that works. Okay, you can also use between and to give a range of values, start here between so and so, and we have already seen how result columns can be renamed using the as keyword, name as student name, roll number as student number, etc. So, this attribute renaming we have already seen, and then use of distinct keyword we can see. If you want in the select clause you can use distinct keyword in order to eliminate duplicates. And then use of this asterisk to retrieve all attribute values. So, select star, it is called select star. So, obtain details of professors along with their department details. So, whatever all the available details you want to obtain along with their department details. So, this will be a wide table, in which case where all the details of the professors concatenated with all the details of the department will be produced. So, so there are a lot of them, and so instead of writing all of them you will just simply put a star there. So, that is how we can make use of this. Okay, good. So, in this lecture basically we have the main thing that we have seen is views, and then there are a lot of other miscellaneous features of SQL that we have looked at. In the next class I will be talking about how we can programmatically access their data in a database, and then with that we will probably wind up the discussion on SQL. Okay.